Hi everyone, this is Boris with Alchemist. Welcome to Qlik Sense. Just to give you a bit of an idea why I'm doing all of this is last week I was at a conference called a Complexity Management Congress, and the idea of what people try to find out there is how they can use data to get a handle on systems that have huge amounts of complexity. Like, for example, when you're configuring a car to purchase, then there's like millions of different variants that you can create this car in. So not only do you have thousands of options that every individual person can configure into this car, but you also have different variants depending on market and geography and stuff. So I think one of these guys said that there are, 3 million different ways how you can build a VW Golf. I thought this is absolutely nuts, right? So I thought maybe there's a data set that I can use to play around with complexity management a little bit myself. And so I found this Lego data set, which is quite interesting and also useful to display some of these challenges that go into complexity management. And I think that Qlik Sense can help a lot to play around with these questions that you ask yourself when you're working inside of complexity management, right? So this is Qlik Sense. It's an app that I will offer for download alongside this video after I've uploaded it. So stay tuned for that. It contains a pretty simple data set. You've got a couple of Lego parts. You've got a couple of Lego sets. Each of these Lego sets is in a different theme, so Star Wars and stuff like that. Then you have parts colors. We've got parts categories. So if it's a place or a brick, I've learned a lot about Lego bricks. Anyway, so to tackle complexity management, what you normally ask yourself is, so do I have a couple of things that are in specific sets or products that are in others as well, and how many different components go into each and every one of them? So you need to like throw together tons of like different bills of materials, different products, and you have to track how these sell to maintain an appropriate level of support for spare parts and all these things. And yeah, so this is what we're trying to look at, right? So I've loaded all of this data into Qlik Sense, and now I can start using the associative model below under Qlik Sense to start interacting with that data, right? So I can select a year. Let's go ahead and select, let's say 1992, for example. And immediately when I click on this, I see that a couple of these values turn gray and others stay white. And this is what is kind of like below the entire associative engine in Qlik Sense. So this means in 1992, I've had a set that was called Wolfpack Tower. It was available then, but I didn't have a set that was called, let's say, 4x4 with catamaran, right? So this already tells me any product that I've released or produced in this year will contain a couple of like components, and it will not contain other components. And I can start making further selections. For example, select Black Knights. You can see there are these 5 sets that have been released in 1992 or were available in 1992 within the theme Black Knight. They contained all of these parts in all of these colors. And then I can start playing around with this as well, right? So say I select a dual defender, and then that had like a brick arch 1x4. I select this, and then I can immediately see that in the year 1992, this brick arch was used in a total of 5 themes, and within the Black Knights theme, in addition to the dual defender, it was also used in the Black Knights Castle and the Black Knights guard shack, sorry. So what this means is, just by playing around with selections and list boxes, I can already discern loads of like information and break into my complexity here, right? So I can see which parts have been used when and where. I can also, by playing with selection states, discern which parts have been used elsewhere and maybe also elsewhere, right? So I can see that this black arch in the Black Knights theme has also been used in 1988 and 1993, right? So another question now would be, why hasn't it been used in 1989 through 1991? But this is something else that you could find out by just playing around with this data, right? So this is list boxes, but what's also loads more interesting is just like having a couple of like visual representations. So if I look at the number of sets within Lego, so there's a total of roughly under 12,000 sets within this data set between 1950 and 2016, and all of these sets are made up of just under 2 million parts, right? So if I look at the of the time development of the number of sets, I can see that it's been constantly increasing since 1950 with a couple of peaks here and there. And then it's been dropping off after 2015. So 2016 is a little bit lower, and then 2017 is really low. But I think that we're lacking a couple of values for 2017 still. So this is, I think that the data is complete up until 2016, and then it must have cut off sometime during 2017. Right. So in addition to having this visual representation of how sets developed, I could also have a look at how the number of available colors have developed. This is something that I've been learning while talking to a couple of Lego heads. People get frustrated with the number of colors that are available now, right? So this is also something that you can see here very well. That we had like peak color in 2005. With a number of 98 different colors, whereas we started off with just 10 in 1950, right? So if we just select 2005 and have a look at what's been available, then it's like this tree map here immediately reduces to 2005, and then what we see here is just every set that has been available in this year, and then each of these boxes is sized according to the number of parts that are available there. These other visualizations show me something that I call diversity. So what this contains is on the y-axis we have the number of distinct parts, so how many different bricks have been in each set, and then we've got the parts quantity on the x-axis, right? So this means that the higher the different bricks that have been used, and also the higher the number of bricks, this means the more value for money you get, depending on what you want, right? So if you want to have like a very diverse set that allows you to build loads of other different things, it's useful to have many different bricks and then also have loads of them. Whereas if you have like just very, very small number of different types of bricks like you would here, so it's just like just 7 distinct parts, but there's 5,500 of them, right? So this would mean that since this is a mosaic, I would guess that these are like these tile glossy parts. If you wanted to have tons of them, then you would probably go for this set, right? And then on the right here, we have a distribution plot. So what this tells me is within each theme, how high is the distribution or the diversity with regards to parts quantity, or how evenly distributed is part number within different themes, right? So what we can see here is, for example, that in this basic set we've got loads of sets which have like a lower number of individual parts, and then also we have a couple of sets at the top here. Whereas here we've got a pretty even distribution, and then there's others which are pretty bottom heavy, like this Knight's Kingdom, for example. So you can see that there's just like tons of them at the bottom, and then there's one probably headline set, which is Vladic's Dark Fortress, which has the most parts in this set, right? So this is how I could use visualizations within Qlik Sense to get a grip on diversity. So we have like a pretty good overview of what each individual year looked like with regards to different products and the number of parts that have gone into each of these products. And then I can look at the diversity, so the how high or how many sets do I have that have loads of different parts and also have loads of parts, and then I can see a distribution of within product categories, how high the distribution of individual parts is within each of these categories with regards to the product that has been going into it. Right, so I can use visualizations to really help me understand bills of materials and also complexity within my products. With Qlik Sense being a web-based solution, there's also something that I love to do, which is called set analysis. Qlik developers might smirk a little bit, but this is not what you think. This is analyzing which parts are available within each set inside of the Lego universe. So if I go ahead and say I've got a couple of these pictures, I can pull them in from Bricklink or from websites like Rebrickable by just using the set number and then pulling this image live from their website, because since this is a web-based solution and I can use Climber cards, which is the extension that is used to display this data, I can just pull in this image from a foreign website as well. So if I select this firehouse, for example, what happens is this middle table here will display all of the parts that have been used in the firehouse. And then this table on the right here will be a visual representation or a detailed representation of which colors have been used in this set, right? So this will give me a rough overview of the color scheme that the finished product will have. And I can also select like a specific part, like this brick here, for example. I can see in which colors this brick has been used within this set. Right? If I say, okay, I'm really interested, or I've got tons of bricks in 1x3 and tan, for example. So I can ask myself the question, which other sets could I build using this brick? And then I just throw away the selection on the firehouse and can see, okay, this Big Ben had like tons of these bricks as well, 41. The model townhouse had tons of these bricks as well. So if I just select the model townhouse and throw away the selection on the part number here on the brick, I can see which other tan colored bricks have been used in this house. And also I can throw away the color's name to get an image of what other bricks have been used, right? So this is also really, really useful, right? With this being a web-based application, I can pull images from my online catalog. I can pull it directly out of my online store alongside any information that I have with regards to the products that I'm selling online or that I have anywhere, and I can give anybody who's trying to get a handle on bill of material, on like product composition or complexity, give them like visual aids to understand what these individual products in each individual product category have been made out of, right? And I can also have a look at numbers and colors, obviously. Then what I also find quite interesting is that if I go for a specific theme, like for example Aquanauts here, I have a product or a set that is called Crystal Crawler, and this Crystal Crawler is been available apparently in two different editions, one with 97 parts and one with 96, right? So this can be something where I try to understand how do these actually differ, right? Normally I would have to go through each individual part and see which has been missing in the other one and then whether it was available or not. And with there being just one part difference, this can be really, really gruesome, right? So it's only 96 here or 97, but imagine if this would be tenfold, it'd be really, really annoying to go through all of these things. This is where the associative model within Qlik Sense becomes really helpful again. Right? So looking at this table, I can immediately see which part has been missing from the other version in 1996. So apparently there was one with the plastic seafloor play stage, and then there was one which didn't have that, right? I just got this information by just looking at this table, didn't have to search, didn't have to compare, didn't have to do anything. Right, and then I also have like this heat map on the side here where I can discern the same information by just looking at colors, right? So there's a white spot here where the plastic C4 plate is. The thing is, like, this set has only one part difference. There's another set that is very, very popular, which is called the Black Seas Barracuda, which is this amazing pirate ship that was available in LEGO back in the day, which has loads more different parts. And as you can see is that the total part number is not that much different, but it's got loads of differences between these two versions from 1989 and 2002. So I can see that this plate again here hasn't been used in a newer version, and then you've got a couple of elements, or got a couple of components or bricks in this case, which have been used in different quantities in each of these releases, and then also you have a couple of elements that have not been entirely in the new version of this product. And this is just information that I can just see by looking at these tables and using this. So this is where this associative model that is used within Qlik is really, really useful to find differences between seemingly similar or identical products that have similar bills of material. Right, just looking at this, I can see this was 921. This is 920 parts. Doesn't look too different, but if I look at these visual representations, I can immediately see where the differences between these two the differently configured products have been. right? So that's it from my side today. Thanks very much for bearing with me and having a look at Qlik Sense. Qlik Sense will be available for download, just to QVF, and then you will have to download the Climber Cards extension to be able to use it in its entirety. Thanks for watching. Looking forward to seeing your comments. Speak soon. Bye-bye.